So hyperbolas I can go faster with because mathematically a lot of what we do with ellipses we do with hyperbolas. I tend to think of hyperbolas as I've taken an ellipse and just moved the foci outside of the ellipse, which has the effect of turning my ellipse inside out and giving us the hyperbola shapes. Um, Now, because of this, our major axis is not always going to be the larger axis. Uh, our major axis is leading to us to where the vertices of the hyperbola are, I should say. And the minor axis is determining how wide our hyperbola opens. So what we look at here is a squared will always be the first denominator, and we do have subtraction now, and this is new for us. We haven't had subtraction in these conics until now. If the x comes before subtraction, in other words, x is over the a squared, then this is a horizontal hyperbola, meaning our hyperbola curves are opening left and right. If y comes before the subtraction, that means it's a vertical hyperbola, meaning our hyperbola curves are opening up and down. C is again the distance to our foci, but our foci need to be outside and further away from the center than the vertices are. So we're doing a squared plus b squared this time. So kind of graphically, what's happening? Here I'm given the equation in this form. I look at it as, well, I have x minus 2, so oops, I moved the 2, my x to the right and my y one down, so my center is at 2, 1. Because x comes first before the subtraction, this is horizontal, meaning that my hyperbola is going to be opening to the left and right. Curves are. I can see that a squared is 16, which means a is 4. B squared is 9, which means that b is 3. That also means that c squared is a squared plus b squared. So my c is 5. So graphically, what I'm looking at is the center is at 2, 1. Horizontal, so that means I'm going to the left and right with my A. So I go to the right 4, 1, 2, 3, 4. I go to the left 4, 1, 2, 3, 4. Those are the vertices for my hyperbola curves. But then the B helps me determine how wide they're going to be. So my B, I'm going to go, because A went left and right, B is going up and down. So from the center up 3, and from the center down 3. And if I make a box out of this, the diagonals of this box will act as the asymptotes that my hyperbola curves have to approach when I draw the curves. So because x came above the a squared, opening left and right, there's the graph of my hyperbola. Now to find the coordinates of the foci have to be further away from the center than the vertices do. So that's why we have to do c is a squared plus b squared instead of minus like the ellipse where we want the foci closer. So because this is horizontal, that means I'm moving left and right. So my foci, I have to move from the center right 5. So 2 plus 5 is 7. And I have to move from the center left 5, which would put me at negative 3, 1. So at negative 3, 1, and at 7, 5. And there are our foci. Now the other example I saw there, I didn't see one where you had to recognize and do completing the square with hyperbolas, but I did see that you had to do one where they gave you information about the graph. So they told us the vertices are at 0, 16, and 0, negative 16. So things I can tell from this. Again, just like with an ellipse, this tells me that my center is the midpoints of these. So my center will be at 0, 0. And the foci actually tell me the same thing. I can also see that this is going to be vertical because I'm moving up and down to get to the vertices, and I'm moving up and down for the foci. But then from the vertices, this tells me that 2a, I'm sorry, I can see that a, the distance I'm moving from the center to one vertex, is 16. And from my foci, I can see that c is going to be 34 because that's the distance from the center to each foci. Well then, using both of these, a squared plus b squared has to be c squared. So 16 squared plus b squared is equal 34 squared. So 256 plus b squared equals 1156, and b squared equals 900. And b does equal 30, but again, I don't need to know b because the equation only requires b squared. So if I look at, oops, because this is vertical, I would actually have it as y minus k goes first over a squared minus x minus h squared over b squared equals 1. And it will always equal 1, just like the ellipse. So my center was at 0, 0. So I have a y squared, I have an x squared. A squared is 16 squared, which is 256. We found that b squared was 900. And there's the equation for our hyperbola.